Okay, can you see the sticky lab again? Here, this is our topology. You just complete this first. How we'll complete this? Let me save it. Okay, let me take 3 switches. For example, this, just connect. Can you see? Oh, you can see. Okay. Can you see? Can you see packet tracer?
Yes, sir.
Let us look. Okay, this is the topology. Just observe ports are going to up state. You will see that one link or one port will be in blocking state, and other it will take time. Okay. Meanwhile, you okay, let me share this. Okay. You will perform this lab. Just take the PDF lab manual. Okay, look at this topology. Look on switch 2, you see that 1 gigabit 01 is blocking a state, and you let me show you which one is. Sure. Show a spanning tree. Spanning tree. Show a spanning tree command. Right. Look here. You will see that there is breeze ID. What is breeze ID? See that it has default priorities 32769. It is default on switches. Actually, priority also included the VLAN ID. By default, VLAN ID is 1, and actually its priority is 32768 plus 1. And another thing is that address. Address is actually MAC address. And breeze ID is actually MAC priority and breeze ID consists of two parts. One part is priority, another part is MAC address. As the priorities are by default the same on all switches, that is, it has no effect on selecting the root switch. There will be root switch with lowest breeze ID. So you will what you will do in this table, complete the breeze ID. Just write in this format, and we'll see which one is the breeze ID. And if we and let me show, for example, this. Which one? Which one? 2, 0. Look, this is root switch or root bridge. Here you will see it, and bridge priority. uh, sorry that my network is very unstable today. Are you working with this lab?
So the PPT article, the PDF is not available.
Sorry, got the PDF?
No, sir, I don't.
I think it is better today if you consider doing by yourself so that we can save more time to do many labs. Because last week we see that we have only completed one lab. So if you consider doing it by yourself, we can at least speed up.
Sorry, I cannot hear you clearly. Can you repeat?
Yes, sir. I said that it is much better if you consider doing it by yourself so that we can save some time. And later we can practice it and then we can show you in the next lab. I think with this we can practice more lab. Can you hear me, sir?
Okay, I am showing this. You can see, share with you. Host visible. Who is host now? My host is changed actually. Someone became the page. You can try with my PDF lab manual. You will be able to finish this and try it with. Meanwhile, I cannot share a screen because it is again down. Okay. Here, going with the so at first, write this breeze ID, sorry, breeze ID from here in the in these tables, and write down which port is blocking. Actually, remaining ports are in forwarding state. our aim of this lab is to check and identify which switch is root bridge, and then we will change the root switch using command, and to change the priority value. And in this way, we will be able to change, and the command will be, for example, spanning tree VLAN one priority will be lower priority. Here, the smaller the priority, it has the higher priority, reverse. So what will be the priority? Priority value will be from 0 to 61 and 440 in this range, but it must be multiple of 4096. For example, first one will be 0, and then 4096, then multiple of 2, and in this way we will be able to get this value. What is our default value? Default value is much higher. That is, if we set another a smaller value, it will be root switch. For example, if we give this command, in this packet switch, packet tracer topology, switch 1 is root switch. For example, we want to make switch 0 roots. In that case, we have to put if we change the default priority, let's see.
So we cannot see anything.
Or you can say, so let's share, 0, 0. Okay, we put this command. Okay, we executed this command on switch 0. Let's see what is happening. Okay, it is changing. Okay, now this port is in blocking state. Earlier, switch 2, gigabit 2 was in blocking state. So let's check which is root switch now. It is shared. So a spinning tree. Okay. Look, this is now root. And its priority is 8193. What was our priority? What was the priority set? It is 8192. Look at our 8192. Why here 93? Because default VLAN is 1, 1 is added to this priority. If there was if you work with different VLAN, for example, VLAN 12, then 12 would be added. So, sorry. Within 5 minutes, can you complete this lab? Just 5 minutes. Now it is 10:58. You will complete it 11:05. Just right. Then we will go to another lab. If any one face any problem, let me know.
So it is completed. Okay.
Oh, completed.
Yes,
Okay.
sir.
Uh, what about other? Halima, did you complete? What about Ali? Can you hear me? Red one. What about Nazneen? Did you complete it?
Assalamu alaikum, sir. Not yet.
How long do you need more? What about EIA?
Yes, sir.
Your configuration completed?
Not yet, sir.
Okay, finish it as soon as possible. Okay, I hope you have completed. It is very short time lab actually. It has no complex configuration or time-consuming configuration.
So we can proceed.
Hello?
We can proceed, sir.
You are also in progress or completed?
Everyone is completed. I think.
Yeah, great. What about,
Sir,
yes?
about the priority, can we use the same priority number? H192? I mean, for all. Can we use it, or we should looking for another one?
It
That is
must
multiple.
be multiple of, it must be multiple of, what I say?
4096.
Yeah, 4096, yeah, 409.
I mean, can we use the same one, or
No,
use
you can use any number. You can any number, but make sure that it is lower than 32768, because we want to make the switch, the root switch. That is, it should be lower. It should be lower than other values. Okay. That is why we choose. It is not mandatory that you will use 8196. You can just 4096 also. You can use any other values up to. Okay, let me. Good question. Actually, in real life networking, we rarely work with STP. Let me show you. We rarely use it. However, we may need to configure STP in some places where we try to change or we want to make sure that our specific link is up or blocking its space. So in that case, we need it. So we will this value 040968192, for example, 12288 up to 32768. This is default value. Alternatively, we can choose, we can set other two switches priority value higher to this and keeping these switches priority unchanged. In that case, also this switch will be root switch. It's clear?
Yes, sir.
Yes, sir.
Okay.
So some said that in real scenario, we can hardly use STP protocol. So how do we prevent loop in real life scenario? Which protocol do we use?
Actually, traditionally, in most switches, STP spanning tree protocol is implemented, and there are other protocols such as rapid spinning. Nowadays, rapid spinning tree is used. Rapid spinning tree is used because it works rapidly. That means it takes less time to convert. You notice that when we connect those switches with cable, we need some time. Although it is very less time in normal sense, but in some cases it has significant impact on network. That is why we need to reduce this time. That is why rapid spinning tree is used. Other variants of spinning trees per billion spinning tree. Sometimes we configure switches with a spinning tree per billion basis. That is, for 1 billion, this port will be blocked. For other billion, another port will be blocked. That is, load can be shared among links. So for VLAN, PBST is another option, but we will not go in detail for those variant of a spanning tree because those are out of scope of CCNA course. In CCNA course, STP or rapid spanning tree protocol RSTP is enough for discussion. Rapid spanning tree and spanning tree works more or less the same way, but there are some differences. If you understand STP, then it is enough for understanding the RSTP, rapid spanning tree. So in real life, what was your question? Can you explain further?
Yes, I said that you mentioned that a real life scenario, we can hardly use STP to prevent looping. So my question is that how do we prevent a looping in real life scenario? And the protocol that you just mentioned, is it a particular protocol itself or is it a mode in STP?
No, it is newer switches work with a rapid spanning tree, or you can change, but a spanning tree. It is, of course, the spanning tree, but there are some differences of type of protocols. What I mentioned, rapid spanning tree. Rapid spanning tree is now available in most switches, but they are same, quite similar, the spanning tree and rapid spanning tree. But you have nothing to set the protocol because this protocol is by default are configured in switches. What you will do, you will just manipulate the priority values in some places to change the block link. For example, in this topology, what you can see in you on the screen, that is one port is switch ones, switch zeros, one port is blocking state. Is what is the color? Is yellow. Yellow means this is block, and green means it is carrying traffic. So for some reason, you may need to change the block link, and you want to make it operational so that it will carry traffic and other link will be blocked. So in that case, you will just manipulate this value. And you are not enabling or disabling STP because it is by default working. It is not clear.
Yes.
Okay. We will go to the another STP related. That is also very easy. I am just describing. You will complete yourself. If you understand this lab of STP, that is enough, I think. But you can study about rapid spanning RSTP, which is quite similar. Okay, let's proceed with another lab.
So,
Yes.
why is the priority after setting it? It is not static. It is always changing after some minute.
Priority is changing.
Yeah.
No, priority value is default value. You have, if you have changed, then it is changed. Otherwise, it is fixed.
No, it has changed.
Okay, okay. Let me connect one. Switch to. Look, I just log in one switch. Okay. Where is CLI? Show a spinning tree. Okay. Here you see bridge ID. Can you see?
Yes, sir.
32769. It is default value. It will not be changed automatically unless you change it.
So mine is changing, sir.
It's very strange.
Yes, sir.
Can you show me what is the case? How
Okay,
is-
sir.
Okay, I am giving you Abdul. Okay, giving
Yes,
you
sir.
I am making you host. Did you connect with two devices or more or one?
Only two. The two exactly as you gave the size.
Then how? Which one is your computer? How can I understand? Okay, I am giving you. Okay, I am making host. I made you host. Okay. Share your screen.
Okay. Is it visible?
Yeah,
Okay.
going yes. Okay. Can you make your screen larger?
Okay.
Okay. It is your switch 0, right?
Yes, sir. So here, if you see, I just made the priority to be
8192.
8192.
Yeah.
So after setting the value 8192, I just execute show span. So you see the value did not it didn't take the value. It did not take the value. I also executed it the second time.
No,
So that
just run the command. Just
yeah,
press command.
this is it. I just executed. So after running the command show span, so it took the value 8193.
Oh, I mentioned maybe you missed this. With priority, VLAN ID will be added.
No, it's not that say. I know it will be added. This one is not the problem. The problem is that after some minute, I just
Okay.
executed show plan again, and you see the value has changed from 81 to 497 97. This is the default value that I just set 8193. So now after some minute,
I
I
understand.
just execute the same show span and the value has changed to 40997. And now also if I execute it, it's always taking the 4097. You see, the value is just coming.
This is
Okay.
happening with
Okay.
the
Please run the command again.
Okay.
Show sparing free.
You see, it is always taking the 4097 while I just set the value to 81992.
No. 81. No. Oh.
So ours is
No,
not
no,
changing.
but problem if it's not changing actually.
this
Yeah,
one. This one is the root bridge.
Let me explain.
and
That is the ID of root bridge.
Yes,
Your- yeah.
I make it the root bridge.
Okay. There is one. There is one
Lower information.
root bridge. There is one switch is root bridge. Or
Yeah,
root
this
switch,
is
right?
it. This is I make it like the span VLAN one root primary. I make it the root, so I just
No.
executed the
Actually, maybe that command is making some issues. But actually, we should not run both commands. That command I provided you to make you understand that we can use this command alternatively, not simultaneously.
okay.
Okay, you use both commands, but you should not use you specify specific. I understand what is your problem. You can specify the priority value. Okay, then it is enough. Or alternatively, you can set the primary command, make it primary, primary, or in that case, it will automatically set the priority value. That is why it is changing. Okay, do not use
Okay.
second command. I just mentioned and that you can use it alternatively. Okay, clear it?
Okay, sir.
Okay, thank you. Just give me the first option. Okay, we are going to another STP related lab. It is called a spanning tree port pass for access ports. What is this? When we connect a host, for example, a computer to a switch port with cable, what it happens? There are different stages of a spanning tree. At first, it will be in blocking, then it is listening about BPDU, bridge protocol data unit, and then it will be listening mode, then learning mode, then it will be in forwarding. That is, it takes at least 1 minute, or you can change it by setting time. But what about we want to make the port operational in shorter time or less time? You may ask you why we want to make it short or less than 60 seconds. There are some protocols that may not work if it is 60 seconds or sometimes more. For example, DHCP protocol may not work. When a computer is connected to a switch port, at some point it will try to get IP address from DHCP. But DHCP handshake or communication may be hampered if port is not operational within 6 minutes or less time. So that is why we want to make the switch port convergence time shorter. So what the command we will use it with port pass for access. The command will be like in the interface. You will go to a specific interface. For example, you can also use range. For example, 1 to 2 here, and switch port mode access. You know, access port is used for host, and switch port access VLAN 10. Here space is named, however. 10, for example, 10 VLAN is used, and a spanning tree port pass. Just you will use this command, and you will show that your port is up quickly. For example, if we add can you see the packet tracer?
No, sir.
If you connect a computer to this switch, let's do this. Okay, it is in yellow state. In real switch, you will say yellow LED is
Cannot see, sir.
okay. that case, we have to wait. But with port passed, you will be able to look. We needed 60 seconds around. But now it is operational. It is green. STP convergence.
So we can see only the PDF.
You see only PDF. I talked about this. I added a PC with this. Okay. It took around 60 seconds to make the first Ethernet port 01 up and running. What about the command that we want to make this time shorter? We will use this command, spanning tree port pass. Okay, I am sharing this.
So Sam, my question is that can we postpone all the switching port at once? Because it is very impractical if we have, let's say, 24 computers connected to a switching port. To say that we can bypass all the port. I said that at once, can we bypass all the switching port, 24 port of the switch at once? Because we know that it is very impractical to connect, let's say, 15 computers and postponing all the switching port, let's say, individually to take time, and it is very impractical, cannot be possible in real scenario. So can we give one command that will bypass all the 24 port switch?
Oh, is global configuration, right? You are talking about? No.
I mean,
you want you are asking that if we have 24 ports, for example, in a switch, should
Yes,
we do that separately? Do the configuration separately, or on a port, on every port?
yes,
Right?
Yes, sir.
Okay. You can do it using a range command, for example.
Okay.
In that case, you can specify whole range. Look at this here. For example, example configuration here. Interface range first Ethernet 1 to 24. In that case, all the ports will be with this command. Okay. This is one way. Another is there any global option? Global right now, I'm not sure actually. I have to check it whether we can give it globally. Global means without specifying any port. However, in most cases, we use it on port by port basis. Okay, this is the command spanning tree port pass. So it will make your convergence time much shorter because it will not go to the list. It will be just forwarding. It will turn the port to forwarding state without going to learning phase. It will skip some stages, and then it will be operational port. Okay, here is all commands. It is easier actually. I think if you try yourself, you will be able to do it very easy because I defined VLAN 10. Then I used here three in the topology. I used 3 pieces. You will of course use 3 pieces just to see the differences. For port PC1 and PC2, you will specify the port pass. For PC3, do not do that. and you will be able to observe what is the difference. Okay, the only difference, only command is a spinning tree put first, and VLAN commands are known, is familiar to you because you know how to configure VLAN access port in earlier labs. And how you check it, if you run show running configuration, you will show it, or you can specify show a spinning tree interface a specific port and detail, then you will be able to see. Actually, we will move to another lab, which is more important or tougher, I will say. We will talk about link aggregation. I'm sharing this. Are you getting the labs I'm sending? Link aggregation. Okay. Please share all this. Okay. Okay. It is an important lab in practical life. Link aggregation. What is link aggregation? Where you have a link between two switches, for example. One link is 1 Gbps. For some reason, you need 8 Gbps link. What you will do? You will bundle together 8 1 Gbps link that will make 8 Gbps. Okay, or you can do it with 2-3 links also, up to 8 links in most switches, and you will get higher bandwidth. In this topology, look at this. We have 3 switches with 2 links, and we will aggregate links so that we will get higher bandwidth. It is a very important concept for practical networking. To aggregate, we use 3 different types of protocol. One is link aggregation control protocol, LSTP, which is often a standard, and PAAGP, port aggregation protocol. It is Cisco's proprietary protocol. It cannot be used with other switches. Other switches means other vendor switches. For example, if you buy a Juniper switch or MikroTik, and it will not work. And another we have static or manual. Okay. Here we have 3 switches, switch 1, 2, 3, and we are connecting every switch with 2 links with other switches, and we will aggregate this link. To check 3 types of protocol, we use 3 pair of links, and for one pair link, we will use LSTP, which is often a standard, and another we will use Cisco's proprietary protocol, PAGP, and for other we will use static protocol. This is our topology. What we will do, we will create, sorry, what is our task one? Task one will give the host name to these switches. Then we will give what to task two, we will create VLAN, 2 VLANs, and we will configure switch port in trunk mode. All these ports will be trunk mode. There is no access issue. Okay. And the configuration commands we will use fast Ethernet ports. Okay. Just we will use 1 to 4, just trunk mode. We are using the range command. Range command is important when we use same command on more than one port, that we can use it. Otherwise, we have to run 4 times. Okay. So here this figure is important. We have to configure on both sides. Both sides means links exist between 2 switches. So, for example, if we configure switch 1, then we have to configure in switch 2. Okay, link aggregation has some names. For example, channel group is used. Channel group 1, for example. You can give a name, a channel group. For example, channel group 1, 2. It's arbitrary. It's up to you how to keep track. Okay. For example, channel group is used to indicate that these ports are bundled. For example, here on switch 1, port 1 gigabit 01, gigabit 02. These two will be bundled into channel group 1. Okay, channel group 1 means these two are bundled together. And this, if one link is 1 Gbps and 2 will form a link that is 2 Gbps. So this figure is important. We relate some instruction about the configuration. For example, if channel group mode is desirable in one side, on the other side you can use same desirable or auto. Then this link will be bundled together. In case of Cisco's proprietary port aggregation protocol. In case of link aggregation control protocol, you will just use in one side active, on other side it is active or passive. Both will work. This is important for configuration. You have to take note for this before you configure. Look at this.
Sir,
Yes.
sir. Yeah, I have a question from the diagram.
Yes.
So how can we avoid the bottleneck problem here? Can we go back to the picture, please?
Sorry.
Can you go back to the diagram? The diagram,
Yeah.
network topology. Yes, sir. You see that
Topology.
here we
Okay.
have-
Network topology. Okay.
Hmm.
Go to
No, the diagram
yeah, diagram.
the lower one. Can you go down, please?
Oh, hold on. Are you talking about
Yeah,
this?
yeah.
This.
Yes, sir. So
Okay.
here we see that we use tooling to carry one traffic. So if we use
Yeah.
tooling to carry one traffic, and then we connect our computer with one link. So how can we avoid bottleneck problem? Because here, let's say here we have 10 Mbps, but if we connect our computer with the switch, we can only, let's say, achieve 5 Mbps. So what is the essence of aggregating these two links, because the link between the switch to computer cannot handle 10 Mbps. So what is the essence of aggregating here? You understand the question, sir?
Maybe I am not 100% clear.
Okay.
Are you talking about this
Yes, sir.
link? Actually, every link has a specific capacity, of course, and we will aggregate them.
So, sir, if we aggregate them, we'll get a high Mbps, right? High data rate. That is high bandwidth between the two switch. But what if we connect another, let's say, another cable to our computer, which will only carry 5 Mbps? So here there would be a bottleneck over there. How can we avoid it? Because here we can achieve 10 Mbps. But if we send it to switch will pass it to the computer, but the computer can only accept like 5 Mbps. So what is the essence? I mean, what is the essence of
No,
aggregating the two?
actually, it depends on scenario. For example, if you have a server, for PC it
Yes.
is not necessary. If
Okay.
you have a server, for example, we initially you connected with 1 Gbps. Okay. For
Yes, sir.
some reason, for some time, you saw that your servers need at least 2 Gbps because your websites are hit by more users. In that case, you will add another link and configure it link aggregation control protocol. That is, you will bundle together two physical link.
Yep.
For switch to switch, you also need more bandwidth. In that case, you will also upgrade your trunk links also. So you will upgrade it. Then what is your issue? I am not clear.
Yeah, I understand now. So this concept will only be applied to servers, not with the PC. I understand.
No,
Because if you use the PC, there is no essence of aggregation.
no.
For the server, it makes sense.
Actually, yes. These are the issues with actually servers or network issues.
Yeah,
Not your user. User PC, 1 Gbps link is normally enough. Okay. We'll configure on switches and link aggregation commands here. Look at this interface. Fast Ethernet 1.2, for example, here 1.2. In our topology, this is actually fast Ethernet connection, not this figure. This figure is used just for command instruction. Okay. Here we set channel group 1 mode active. This means fast Ethernet 0, 1 and 2 will be bundled together in channel group 1. Okay. And another 2 ports, 3 and 4 will be bundled together port group 2. And active and desirable, you will follow. Active means and another side, for example, in switch, in passive, active, passive. So they will form the link aggregation channel group. You can also here use mode active also, as per this figure. In one side you can use active, in on our side you can active or passive in case of LSP. In case of port aggregation, you will use on one side desirable, at other end desirable or auto. Okay, and for static we will just use mode on. Okay, on both sides. On both sides you will use on, then they will form. And how you will check that your port channel or channel group there are some languages interchangeably used. Ether channel, port channel, actually used interchangeably to indicate the same thing. So when you run the command show ether channel summary, you will show, look at this on switch 1, PO01, that is port channel 1 and port channel 2. One is used with protocol. Protocol is mentioned LSCP. Which to put port 1 and 2, fast Ethernet port 1 and 2 are bundled together to form port channel 1. And port channel 3 and 4 are bundled together to form port channel 2. It is used, the protocol used here is port aggregation protocol, which is Cisco's proprietary. But in real life, we will try to use LSCP in most cases because we should use open standard as much as possible. And for switch 2, you are seeing that port 1, fast Ethernet 1 and 2 are bundled together to form the channel group 1 PO01, and protocol is LSCP, and 3, 4 are bundled together in port channel 3, and here is blank. That means it is manual. The protocol LSCPs and PAGPs are not used here. Okay. If you can configure this lab, and you will be able to use 3 different protocols for linked aggregation. In the last session, I provided you a lab which was simpler, just what I mentioned to do with. You used, that was manual configuration. There was no LSCP or PGP. Okay. I hope you will be able to complete it yourself because our time is very limited. So I am just giving you the idea how you will perform. Everything is mentioned here. Ports are also mentioned. You will configure according to this topology. Then you can also follow the commands at first. After you practice at least once, then you will be able to choose ports as you wish. No problem. Can you understand all these issues with this lab? Or if you have question, ask me. Then you will configure it yourself. Everybody understands?
Yes, sir.
What about Usman? Can you understand?
Yes, sir.
Okay, great. Okay. You will. It will take time. I think you should practice all these labs today, and then you will ask. I have prepared or planned to practice for you practice other some labs which are important. Just I am showing the concepts You will practice them today, and I hope it will not take much time. Okay, another lab is important. So this quick portfolio. PDF. Can you see this? Another important
Yes, sir.
issue is port security. Nowadays, cyber security is important. We have to ensure security at layer 2, at layer 1. At every layer, we have to ensure security. So for switch ports, there maybe there are some cables are exposed in the table, on the table, or on a table. Some users, malicious users, can connect to the PC with this cable, and they can do some unauthorized activity. So to protect this, what we do, we just restrict the switch ports for a specific computer. How we can do it? We know that every device, for example, every laptop or desktop has its MAC address. So we can specify that this switch port can work with this MAC address, and we can specify the MAC address. So we can do that into we can collect the MAC address from the device and specify in the switch configuration, or we can use sticky MAC. Sticky MAC means once you connect to a switch port, switch will learn your MAC address and make it specific that this MAC should be used in future. Otherwise, if other MAC comes to this port will be automatically blocked. So switch port security, if you put this command switch port security, then question mark, you will get aging MAC address maximum violation, this option. And we'll, okay, we are describing soon. And then what will be the actions? The action could be they will protect it. Switch will protect your this security. Security will be protected. How? They will make log. Okay. It will not make log entry for drop frames. But this option works with only sticky option, and then it will restrict, it will shut down. Restrict means if different MAC address comes to the port, it will be dropped. And when you connect your authorized MAC address, then it will transfer. And shutdown, there is another option. Shutdown means if there is some unauthorized MAC address, then it will, this port will be shut down. Even when you connect your authorized computer to the port, it will not be operational unless network administrator connects to the switch and run the no shutdown command or other command also. Okay. Look, how we bind the MAC address. You know that this command name, what is name? Actually, there is mistake. It is actually host name switch W1. Okay, you should skip this command over. Okay, for port 1, it is connected to PC1. What is our topology? What is the topology? Here is the topology. Okay. We have 3 ports. PC 1, 2, and 3. For one PC1 will configure manual, and PC2 will use sticky, and PC2 will not configure any port security. What we will do, here is another new command for switch port security MAC address, then MAC address. How can you get MAC address? You will get MAC address from computer, but in packet tracer you can get it from MAC address table, and then you will specify. And then switch port security maximum 1. That is, if other computer is used or connected to this port, then what will happen? Switch port security violation shutdown. What we said that there is different options. Aging means you can specify some time, MAC address, and maximum. Maximum means how many MAC address we can allow. For example, if a hub is connected to a switch port, in that case, we can allow more than 1 MAC address. But hubs are not used nowadays. So violation means if port security is violated, then these actions, these options can be used: protect, restrict, shutdown. So here we used shutdown. That means if someone uses a computer with different MAC address, the switch port will be automatically shut down. Okay, and network engineer or network administrator will run the no shutdown command on this port, and then it will be off when. Then sticky MAC address. Okay. Okay.
I need to specify the more than 1 MAC address. Do I need to specify the MAC address? For example, I need to allow more than 1 MAC address to access the switching port. So do I need to specify the MAC address?
Yes, you can use.
For example, here you say maximum 1. Let's say we need to allow 2.
No,
MAC
maximum
address.
1 means I configured here 1. If you are very restrictive for security, for example, we normally use 1 computer in 1 port in most cases. However, if there is any case where a port is used by 2 or more people, in that case, you can specify more. Maximum, for example, maximum 2, 3.
So if
Okay.
you do that, do you need to specify the MAC address in the above
Yes,
command?
you will
Is this
specify.
response?
Of course, you have to specify. In that case, you specify that 3 MAC address. If 4th one comes and try to use that port or that cable, and he or she will not be able to access the network. Okay,
Yes.
clear? Okay. And then another option is MAC address, sticky MAC address. Here, if you have to collect the MAC address and specify here, it is sometimes difficult for some network engineer. So option is sticky MAC address. The sticky MAC address is easier. Just ask your user to connect to the port, and your switch port or your switch obtains the MAC address automatically, and you will run the command. What is your command? Switch port security MAC address is sticky. That means the MAC address that is connected now. Okay, this is sticky. Here is also the maximum one. You said just one. Why one? Just to mention that if other MAC address comes to this port, the switch port violation should be action should be shut down. The port will be shut down, and only
So if you assign 2, the switch will learn up to 2 MAC address. In sticky.
yeah. In that case, you will just mention maximum 2. That is two will be allowed, and after that the port will be shut down. You have flexibility. And for third port, for PC3, you will not configure any port security, just for testing. And how can you test it? You will just delete or disconnect this PC and connect to other PC with this port, to this port, and you will see the result. Okay. And what are the verification commands? Shows port security. You will see the port security commands are configured, and port security interface. You can also specify interface like fast Ethernet 01 or gigabit Ethernet 01 kind of things. And how we can enable all the port? Just go to the specific port in the switch and run no shutdown, and it will be operational again. And there are another option that is actually not in the scope of CCNA course. It is error disabled recovery cause pre-secure violation in global mode. It is run in global configuration mode. Okay. Okay, option 1 is enough for day-to-day activity. Actually, when you use these security feature in your organization, like an organization where, for example, 1,000 people are working, in that case, if some users are connecting other computers or unauthorized computer in the network, you will detect it easily. From my experience, I can say one thing. I was working at a large organization where there are some people who try to do some IT activity on their own, although they are not IT people. What they try to do, they just connect this cable to other computer, kind of thing. So it was disturbing for IT people because we had database. Our database was quite different after some time. So we decided to implement this feature on all the switches. After that, we noticed that some people are still trying to do this kind of activity, and they are unable to connect this time. And they ask us, what is the problem? And we again warn them, if you continue with this, we will be able to identify, and your computers will be inaccessible immediately. And we must work to make it operational. So after that, this tendency reduced significantly, and also security was ensured. Sometimes people are try to connect their own computer, which are not authorized by IT policy of the company. That was also prevented in this way. Okay. Do
Yes,
you have
sir.
any question regarding this security of system? You will configure it of your own. If we complete all those in this 2 hour window period, I hope all the labs will not be able to be covered. You will do it yourself. Hopefully, you can do it by today, I think. And if you have any problem, just write it down, or you can contact me. No problem.
Sir, I have a quick question.
Okay, sure.
So how does this differ with the MAC address filter of firewall?
May?
How does this differ with the MAC address filtering feature of firewall that we can configure in a router?
Okay, we have not in router. MAC address actually is layer 2 issue, layer 2 address. We have some layer 2 access control ACL. We will discuss layer 2, layer 3 access control list ACL, which is not ACL. We can allow or disallow different IP address, MAC address. We'll discuss it. We have specific session.
Yes, sir. My question is that, is there any difference with this methodology?
No, no, that is different. That is different. Quite different. Although intention could be similar, but there are differences. In this lab or in this port security feature, we just protecting or preventing some users unauthorized users to connect unauthorized devices or unauthorized port. For example, if you have a computer that should be connected to port number 5, for example, it should not be connected to port number 6 for different reasons. For example, port number 6 can be assigned to other VLAN. However, VLAN and will prevent also them to connect that port. But this MAC restriction is more effective, I think, because in that case, only IT people or networking people will be able to handle all this, and they have to maintain the network inventory data, which will be unchanged over time. But in that case, in case there is no port security, some users may change those connectivity, and as an IT people or networking people, you will be confused later when you match your database with the actual scenario. That is the problem. This is the main issue or intention for security. For ACL, we have a slightly different reason. Our main intention is traffic control. For some IP address, we protect some service. For example, we have some service assistant in our company. We don't want them that they will access to Facebook or YouTube and waste their time. So we'll restrict their services on their IP address or computer, but we will allow other services. Okay, we'll show those in access control session. Do you have any other question regarding, or we'll proceed to another lab? Okay, someone tried to ask me anything. Okay. I hope you understand. Okay, we have another Ether channel is covered, and we have BTP. Oh, BTP and DTP is another issue. Okay, let me share again. Everyone. You will get BTP. Okay, virtual trunking protocol. It is sometimes used in a large implementation where there are so many switches are connected. For example, you have to configure VLAN, VLAN trunking protocol, not virtual, VLAN trunking protocol. You have to configure VLANs in one switch, and there are other switches where you should use the same VLAN VLAN. In that case, you have to define VLANs on each switches individually. So here a bit of automation is introduced here. For example, if you configure VLANs on switch 0 and switch 1, you want to get the same VLANs automatically if you configure a trunk between them. How you can do it? You should specify switch 0 as BTP server, then and switch 1 as BTP client, then they will get all the configurations from server automatically, and you don't need to configure there again. So it is a big automation for larger organization. For one or two switch, you can define separately. It's not a big deal, but for a big organization, it is important. So what is the topology here? Switch 0 is server, switch 1 is our client, BTP client. That is, if you configure here and the configuration will be transferred over the trunk link. And we have two PCs also, we can just for checking. And there are some task description. What we will do, we give the host name. What we will do, another important issue, we have to configure a BTP domain. For example, we call it a IUTBD, for example, it's domain, BTP domain. BTP domain means all the members of BTP domain will be able to get the VLAN definition from server. And we can also set some password, BTP password, then we will set a password. And for switch 0, we configured it as a server. All switches are by default server. We don't need to configure them as server. Okay, that is why we have not specified them, because it is configured already. But switch 1, if you specify, sorry, BTP mode can be server, BTP mode can be client, BTP mode can be transparent. Transparent means if one switch is installed between client and server, but that server don't want to get any VLAN information from server, and it can be transparent. That means it will transfer information from client to server, server to client. It will not use that data. That is, it is transparent. Client means it will take VLAN information from server. So we must mention the domain, in which domain. Okay, and we'll show that BTP status. We will see BTP status, and we will configure. Okay, in this figure, we will configure VLAN. For example, we created here two VLANs. VLAN, for example, 10, for example, one VLAN enough for checking, but two VLAN or three VLAN you can create just to see whether these are transferred. Okay, after 5 minutes, you will see the update, or you can change this time, but this is not our scope in this course. Okay, we will configure for VLAN 10 on both switch, and what we will do, we will only define the VLAN in our server, which is switch 0. In switch 1, we will get all the VLAN information and from server. Another thing. Okay, here is another BTP and BTP. Okay. Trunk. Okay, there is another issue, that is we mentioned on switch 1 that switch port mode trunk, but on switch 1 without mentioning we will get the trunk, because normally it is configured as desirable. Okay, do you have any question regarding BTP? Absent. Do you have any question regarding Abdullah, Marjia Khatun, Muhammad, Musa?
Yes, sir.
Are you all present?
Yes, sir.
Can you understand? I think these are easier. You can, if you configure, then it will be much clearer, or just lab manuals guideline. It will be easier. Okay. I have another lab, is CDP and LLDP. I don't think it is. Okay. When we connect to a device, how can we check which device is connected to it? For example, in this topology, you see a router and switch is connected. Okay. And from switch 1, we can see which is your neighboring network device. We can check it using two protocols. One is Cisco Discovery Protocol. It is Cisco's proprietary. It will not work with other vendors' device. It will only work with Cisco devices. And then we have link layer discovery protocol, LDP protocol, that can be used with other devices also in the Cisco network also. Here, what we configured, simpler configuration, we just configured a IP address on this router port, and there is also a switch virtual interface in the switch, and connect them and link is established. And what we'll check after configuring this, you will check just what is the configuration? Cisco shows CDP neighbors detail. You will show the details in the router. If you run the CDP neighbor, that is you are searching your neighbor, you will see that details of the router. Your neighbor is switch 1. From if you run this command from switch 1, these are details, you will show that. And how can we disable this CDP? CDP should be disabled with this command, no CDP run LLDP. Then we will run LLDP. LLDP is enabled here to check. For LLDP, show LLDP neighbors. You will just run this command. Now it is LLDP. LLDP protocol is enabled. CDP is disabled. And more important issue is that when we connect to other company's network, for example, ISP's network, in that case, we disable CDP and LLDP so that they do not get information of our company's device information. That is why we use this protocol. Just try it yourself, and we will be able to. Everyone, I am sharing.
And the PowerPoint, sir.
Okay, I am sending you. Okay, did you got all the? Did you get all the labs PDF manual?
Yes, sir, but only the CCNA training D2 PowerPoint. So many.
Which one?
The first one, CCNA training D2. The PowerPoint slide.
Oh, no, I am not. Oh, I understand. You have not. Okay,
Excuse me, sir.
yes,
Sir, 81, I'm present, sir.
81 is present. Okay.
81,
Okay.
1700 for 1081.
81 is present, right? Okay, I will update.
So even 145, 18 batch. 145.
Okay.
So
Okay.
69 also.
69 also. Okay, try to be present from the beginning. That would be great. Okay, what?
Yes,
Switch
please
virtual
tell-
in. Sorry. Switch virtual was problem. I will check it why this switch was not.
Hi, please, can you mute yourself?
Okay. Okay, try all these labs, and next session I will ask you to present those labs what you did randomly. I will check it randomly and try to practice it and preserve, save all the configuration on your computer so that I can check your labs. Okay.
Okay, sir, can you share the CCNA training slide?
Okay, I will. Okay. It is not also completed. Okay, let me do it. Actually, I am focusing on your lab, as you know, most of the things. Okay, sharing. Okay, I'm giving.
كده انا جاوي يا عبرنا.
Right, mute yourself, please.
Anyone asking anything?
No, sir. No, sir.
Okay. Do you have any question you can ask? Otherwise, we'll finish today. And I hope you will finish all these labs. If you complete all these labs, I think your concepts on switching will be clear. And in next session, we'll focus on IP addressing, how to plan IP address for an organization, and also some routing also. And after that session, and we'll mainly focus on routing. In the outline, you will see how we'll proceed with this. Okay. Today, take it seriously. Today, complete it and preserve all the labs, packet tracer files, and then you will be able to show through screen share in the next session. In the beginning, we will see your task. I will ask you randomly. Be prepared. Okay. Thank you.
Thank you, sir. Thank you very much.